Good day everyone, I am Ninyo Jan P. Coritico. I will be the last reporter to tackle about Article 7.60 or the fire alarm systems. A. In PLFE or the non-power limited fire alarm circuits, wiring methods, and materials. Installation shall be in accordance with 7.60.2.6 and conductor shall be solid or stranded copper. So we have three exceptions. So first, we have the ampacity adjustments for factors given in 3.10.2.6 B 3 A shall not apply. Second, conductors and multi-conductor cables described in and installed in accordance with 7.60.2.9 and 7.62.13 shall be permitted. Third, we have power limited circuits shall be permitted to be reclassified and installed as non-power limited circuits if the power limited fire alarm circuit marking required by 7.60.3.4 are eliminated and the entire circuit is installed using the wiring methods and materials in accordance with Part 7.60.2 non-power limited fire alarm circuits. B. We have PLFE, wiring methods and materials. So, ang PLFE is power limited fire alarm circuits. Power limited fire alarm conductors and cables described in 7.60.4.4 shall be installed as detailed in 7.60.3.10 B1, B2, B3 of these sections and 300.7 devices shall be installed in accordance with 1.10.1.3 B, 3.0.1.11a, and 3.0.1.15. 1. In raceways exposed on ceilings or sidewalls or fish in concealed spaces, cable splices or terminations shall be made in listed fittings, boxes, enclosures, fire alarm devices, or utilization equipment where installed exposed cable shall be adequately supported and installed in such a way that maximum protections against physical damage is afforded by building constructions such as baseboards, door frames, ledges, and so forth. Where located within 2,100 mm of the floor, cable shall be securely fastened in an approved manner and at intervals of not more than 450 mm. Second, passing through a floor or wall. Cable shall be installed in metal raceways or rigid non-metallic conduit where passing through a floor or wall to a height of 2,100 mm above the floor, unless adequate protection can be afforded by building constructions such as detailed in 7.60.3.10 B1 or unless an equivalent solid guard is provided. Third, we have in hoistways. Cable shall be installed in rigid metal conduit, rigid non-metal conduit, intermediate metal conduit, or electrical metallic tubing were installed in hoistways. 7.60.3.13 Installation of conductors and equipment in cables, compartments, cable trays, enclosures, manholes, outlet boxes, device boxes, raceways, and cable routing assemblies for power limited fire alarm systems. Conductors and equipment for power limited fire alarm circuits shall be installed in accordance with 7.60.3.15 through 7.60.3.23. So, we have 7.60.3.15 Installation of PLFE cables in buildings. Installation of power limited fire alarm cables in buildings shall comply with 7.60.3.15a through J. So, A. Listing. PLFE cables installed in buildings shall be listed. B. Ducts specifically fabricated for environmental air. The following cable shall be permitted in ducts specifically fabricated for environmental air as described in 3.01.1.22b if they are directly associated with the air distribution system. 1. Types FPLP and FPLP-CI cables in lengths as short as practicable to perform the required function. Second, types FPLP, FPLP-CI, FPLR, FPLR-CI, FPL, and FPL-CI cables installed in raceways that are installed in compliance with 3.0.1.22b. C. Other spaces used for environmental air or plenums. The following cables shall be permitted in other spaces using environmental air as described in 3.0.1.22c. First, we have type FPLP cables. Second, type FPLP cables installed in plenum communication raceways. Third, type FPLP cables installed in plenums routing assemblies. Fourth, types FPLP and FPLP-CI cables supported by open metallic cable trays or cable tray systems. Fifth, types FPLP, FPLR, and FPL cables installed in raceways that are installed in compliance with 3.0.1.22c. Sixth, we have types FPLP, FPLR, and FPL cables supported by solid bottom metal cable trays with solid metal covers in other spaces used for environmental air or plenums as described in 3.0.1.22c. 7. Types FPLP, FPLR, and FPL cables installed in plenum communications raceways, riser communications raceways, or general purpose communication raceways supported by solid bottom metal cable trays with solid metal covers in other spaces used for environmental air or plenums as described in 3.0.1.22c. So we have next D. Risers, cables in vertical runs. The following cable shall be permitted in vertical runs penetrating one or more floors and in vertical runs in a shaft. First, types FPLP and FPLR cables. Second, types FPLP and FPLR cables installed in the following. A. Plenum communication raceways. B. Plenum cable routing assemblies. C. Riser communication raceways. D. Riser cables routing assemblies. So next we have A. E. Risers, cable in metal raceways. The following cables shall be permitted in metal raceways in a riser having fire stop at each floor. First, we have types FPLP, FPLR, and FPL cables. Second, we have types FPLP, FPLR, and FPL cables installed in the following. First, we have plenum communications raceways. B. Riser communication raceways. C. General purpose communication raceways. So, next we have F. Risers, cables in fireproof shafts. The following cables shall be permitted to be installed in fireproof riser shafts having fire stop at each floor. First, we have types FPLP, FPLR, and FPL cables. Second, we have types FPLP, FPLR, and FPL cables installed in the following. A. Plenum communications raceways. B. Plenum cable routing assemblies. C. Riser communications raceways. D. Riser cable routing assemblies. E. General purpose communications raceways. F. General purpose cable routing assemblies. Next we have G. Risers. 1 and 2 family dwellings. The following cables shall be permitted in 1 and 2 family dwellings. First, types FPLP, FPLR, and FPL cables. Second, we have types FPLP, FPLR, and FPL cables installed in the following. A. Plenum communication raceways. B. Plenum cable routing assemblies. C. Riser communication raceways. D. Riser cable routing assemblies. E. General purpose communication raceways. F. General purpose cable routing assemblies. So, next we have H. Other building locations. The following cables shall be permitted to be installed in building locations other than the locations covered in 7.70.5.4b through H. So first we have types FPLP, FPLR, and FPL cables. Second, we have types FPLP, FPLR, and FPL cables installed in the following. First, we have plenum communications raceways. B. Plenum cable routing assemblies. C. Riser communications raceways. D. Riser cable routing assemblies. E. General purpose communication raceways. F. General purpose cable routing assemblies. So, third, types FPLP, FPLR, and FPL cables installed in raceways of a type recognized in Chapter 3. So next we have I. Non-concealed spaces. Cables specified in Chapter 3 and meeting the requirements of 7.60.6.1a and b shall be permitted to be installed in non-concealed spaces where the exposed length of the cables does not exceed 3,000 mm. Next we have J. Portable fire alarm system. A portable fire alarm system provided to protect a stage or set when not in use shall be permitted to use wiring methods in accordance with 5.3.2.2. Next we have 7.60.3.16. Separation from electric light power class class 1 NFPLFE and medium power network powered broadband and communication circuit conductors. A. General. Power limited fire alarm circuit cables and conductors shall not be placed in any cable tray, compartment, enclosure, manhole, outlet box, device box, raceways, or similar fitting with conductors of electric light power class 1 non-power limited fire alarm circuits and medium power network powered broadband communication circuits unless permitted by 7.60.3.16b through G. B. Separated by barriers. Power limited fire alarm circuit cables shall be permitted to be installed together with class 1 non-power limited fire alarm and medium power network powered broadband communication circuits where they are separated by a barrier. C. Raceways within enclosures. In enclosures, power limited fire alarm circuits shall be permitted to be installed in a raceways within the enclosure to separate them from class 1 non-power limited fire alarm and medium power network powered broadband communication circuits. D. Associated systems within enclosures. Power limited fire alarm conductors in compartments, enclosures, device boxes, outlet boxes, or similar fitting shall be permitted to be installed with electric light power class 1 non-power limited fire alarm and medium power network powered broadband communication circuits where they are introduced solely to connect the equipment connected to power limited fire alarm circuits and comply with either of the following conditions. First, the electric light power class 1 non-power limited fire alarm and medium power network powered broadband communications circuits conductors are routed to maintain a minimum of 6 mm separation from the conductors and cables of power limited fire alarm circuits. Second, the circuit conductors operate at 150 volts or less to ground and also comply with one of the following. First, we have A. The fire alarm power limited circuits are installed using type FPL, FPLR, FPLP, or permitted substitute cables provided these power-limited cables conductors extending beyond the jacket are separated by a minimum of 6 mm or by a non-conductive sleeve or non-conductive barrier from all other conductors. B. The power-limited fire alarm circuits conductors are installed as non-power limited circuits in accordance with 7.60.2.6. Next, we have E. Enclosures with single opening. Power-limited fire alarm circuit conductors entering compartments, enclosures, device boxes, outlet boxes, or similar fitting shall be permitted to be installed with electric light, power, class 1, non-power limited fire alarm, and medium power, network-powered broadband communications circuits, where they are introduced solely to connect the equipment connected to power-limited fire alarm circuits or to other circuits controlled by the fire alarm system to which the other conductors in the enclosures are connected. Where power-limited fire alarm circuit conductors must enter an enclosure that is provided with a single opening, they shall be permitted to enter through a single fitting or such as T, or provided the conductors are separated from the conductors of the other circuits by continuous and firmly fixed non-conductor such as flexible tubing. Next, we have F. In-host-ways. In-host-ways power-limited fire alarm circuits conductor shall be installed in rigid metal conduit, rigid non-metal conduit, intermediate metal conduit, liquid-tight flexible non-metallic conduit, or electrical metallic tubing. For elevators or similar equipment, this conductor shall be permitted to be installed as provided in 6.20.3.1 other. Next, we have G. Other applications. For other applications, power-limited fire alarm circuit conductor shall be separated by at least 50 mm from conductors of any electric light, power, class 1, non-power fire alarm, or medium power network-powered broadband communications circuits unless one of the following condition is met. First, we have either A. All of the electric light, power, class 1, non-power limited fire alarm, and medium power network-powered broadband communication circuit conductors, or B. All of the power limited fire alarm circuit conductors are in raceways or in metal-clad, non-metal sheeted, or type UF cables. Second, we have all of the electric light, power, class 1, non-power limited fire alarm, and medium power network-powered broadband communication circuits conductors are permanently separated from all of the power limited fire alarm circuits conductors by a continuous and firmly fixed non-conductor such as porcelain tubes or flexible tubing, in addition to the insulation on the conductors. Next, we have 7.60.3.19 installation of conductors of different PLFE circuits, class 2, class 3, and communication circuits in the same cable, enclosures, cable tray, raceways, or cable routing assembly. A. 2 or more PLFE circuits. Cable and conductors of 2 or more power limited fire alarm circuits, communication circuits, or class 3 circuits shall be permitted within the same cable, enclosure, cable tray, raceway, or cable routing assembly. B. Class 2 circuits with PLFE circuits. Conductors of 1 or more class 2 circuits shall be permitted within the same cables, enclosures, cable tray, raceways, or cable routing assembly with conductors of power limited fire alarm circuits, provided that the insulation of the class 2 circuit conductors in the cable, enclosure, raceways, or cable routing assembly is at least that required by the power limited fire alarm circuits. C. Low power network powered broadband communications cables and PLFE cables. Low power network powered broadband communications circuits shall be permitted in the same enclosures, cable tray, raceways, or cable routing assembly with PLFA cables. Next, we have D, audio system circuits and PLFA circuits. Audio system circuits described in 6.40.1.9 C and installed using Class 2 or Class 3 wiring methods and compliance with 7.25.3.13 and 7.25.3.34 shall not be permitted to be installed in the same cable tray, raceway, or cable routing assembly with power-limited conductors or cables. Next, we have 7.60.3.22 conductor size. Conductors of 0.125 mm squared shall be permitted only where spliced with a connector listed as suitable for 0.125 mm squared to 0.25 mm squared or larger conductors that are terminated on equipment, or where the 0.125 mm squared conductors are terminated on equipment listed as suitable for 0.125 mm squared conductors. Singles conductor shall not be smaller than 0.75 mm squared. Next, we have 7.60.3.23 support of conductors. Power limited fire alarm circuit conductor shall not be strapped, taped, or attached by any means to the exterior of any conduit or other raceways as means of support. Next, we have 7.60.3.25 current carrying continuous line type fire detectors. A. Applications. Listed continuous line type fire detectors, including insulated copper tubing of pneumatically operated detectors employed for both detection and carrying signaling currents, shall be permitted to be used in power-limited circuits. B. Installation. Continuous line type fire detectors shall be installed in accordance with 7.60.3.4 through 7.60.3.10 and 7.60.3.13. Next, we have 7.60.3.34 applications of listed PLFA cables. PLFA cables shall comply with the requirements described in Table 7.63, Table 7.60.3.34, or where cable substitution are made as shown in 7.60.3.34a. Where substitute cables are installed, the wiring requirements of parts 7.60.1 and 7.60.3 shall apply. Types FPL-PCI, FPL-RCI, and FPL-CI cable shall be permitted to be installed to provide 2R circuit integrity rated cables. So A. Fire alarm cable substitutions. The substitutions for fire alarm cables listed in Table 7.60.3.34a and illustrated in Figure 7.60.3.34a shall be permitted where substitute cables are installed. The wiring requirements of Part 7.60.1 and 7.60.3 shall apply. Next, we have 7.60.4 or the listing requirements. 7.60.4.1 listing and marking of NPLFE cables. Non-power limited fire alarm cables installed as wiring within buildings shall be listed in accordance with 7.60.4.1a and b, and as being resistant to the spread of fire in accordance with 7.60.4.1c through F, and shall be marked in accordance with 7.60.4.1g. Cable used in a wet location shall be listed for use in wet locations or have a moisture impervious metal sheet. Non-power limited fire alarm cable shall have a temperature rating of not less than 60 degrees. A. NPLFE conductor materials. Conductor shall be 0.75 mm squared or larger solid or stranded copper. B. Insulated conductors. Insulation on conductor shall be rated for the system voltage and not less than 600 volts. Insulated conductors 2.0 mm squared and larger shall be one of the types listed in table 3.10.3.1a or one that is identified for this use. Insulated conductors 0.75 mm squared and 1.25 mm squared shall be in accordance with 7.60.2.9. Next, we have C. Type NPLFP. Type NPLFP non-power limited fire alarm cables for use in other space used for environmental air shall be listed as being suitable for use in other space used for environmental air as described in 3.0.1.22c and shall also be listed as having adequate fire resistant and low smoke producing characteristics. Next, we have D. Type NPLFR. Type NPLFR non-power limited fire alarm riser cable shall be listed as being suitable for use in a vertical run, in a shaft, or from floor to floor and shall also be listed as having fire-resistant characteristics capable of preventing the carrying of fire from floor to floor. So we have here the table 7.60.3.34 or table of applications of listed if PLFE cables in buildings. So we can see here the where you have applications in others. You can see the in fabricated ducts as described in 3.01.22b. In other spaces used for environmental air as described in 3.01.22c. In risers within building in other than air handling spaces and risers. So nila ang applications 3. Then ang iyang cable type na murag isang pwede magamit. Like cable type, data cable type 3, FPLP and FPLPCI, in FPLR and FPLRCR, CI, FPL and FPLCI. So mabasa man nato sa table makita nato kung sa tangkuan sa applications o ang iyang corresponding cable type. So we have another table 7.60.3.34a cable substitutions. So we can see we have here cable type FPLP, FPLR, FPL. Yeah, permitted substitution. So is CMP ang pwede i-substitute sa FPLR. CMP, FPLP, CMR sa FPLR. CMP, FPLP, CMR, FPLR, CMG, CM is pwede sa FPL. Then multi-conductor cables, plenum, CMP going to FPLP. Then sa riser, CMR going to FPLR, general purpose, CMG, CM into FPL. So, unang figure 7.63.3.34a cable substitution hierarchy. Kana siya. So, next we have E. Type FPLF. Type FPLF non-power limited fire alarm cable shall be listed as being suitable for general purpose fire alarm use with the exemption of risers, ducts, plenums, and other spaces used for environmental air and shall also be listed as being resistant to spread of fire. F. Fire alarm circuit integrity or CI cable or electrical circuit protective system. Cables that are used for survivability of critical circuits under fire connection shall meet either 7.60.4.1 F1 or F2 as follows. First, we have circuit integrity CI cables. Circuit integrity cables specified in 7.60.4.1c, D, and E and used for survivability of critical circuits shall have an additional classification using the suffix CI or the circuit integrity CI. Cables shall only be permitted to be installed in a raceway where specifically listed and marked as part of an electrical circuit protective system as covered in 7.60.4.1F2. Second, electric circuit protective system. Cables specified in 7.60.4.1C, D, E, and F1 that are part of an electrical circuit protective systems shall be identified with the protective system number and hourly rating printed on the outer jacket of the cable and installed in accordance with the listing of the protective system. So G, NPLFE cables markings. Multi-conductor non-power limited fire alarm cable shall be marked in accordance with Table 7.60.4IG. Non-power limited fire alarm circuit cable shall be permitted to be marked with a maximum usage voltage rating of 150 volts. Cables that are listed for circuit integrity shall be identified with suffix CI as defined in 7.60.4.1F. Temperature rating shall be marked on the jacket of NPLFE cables that have a temperature rating exceeding 60 degrees Celsius. The jacket of NPLFE cable shall be marked with the conductor size. So we can see here another table 7.60.4.1G NPLFE cable markings. So address sa table kay cable marking if NPLFP yang type non-power limited fire alarm circuit cables for use in other space used for environmental air as ang reference 7.60.4.1C and G. Then we have second if NPLFR non-power limited fire alarm circuit riser cable. So isang reference 7.60.4.1D and G. So next we have cable marking na NPLF non-power limited fire alarm circuit cable. So isang reference 7.60.4.1E and G. So next we have 7.60.4.4 listing and marking of PLFE cables and insulated continuous line type fire detectors. PLFE cables installed as wiring within buildings shall be listed as being resistant to the spread of fire and other criteria in accordance with 7.60.4.4a through H and shall be marked in accordance with 7.60.4.4i. Insulated continuous line type fire detector shall be listed in accordance with 7.60.4.4j. Cable used in a wet location shall be listed for use in wet locations or have a moisture impervious metal sheet. So A, conductor materials. Conductor shall be solid or stranded copper. B, conductor size. The size of conductors in a multi-conductor cable shall not be smaller than 0.125 mm squared. Single conductor shall not be smaller than 0.75 mm squared. So next we have ratings. The cable shall have a voltage rating of not less than 300 volts. The cable shall have a temperature rating of not less than 60 degrees Celsius. D, type FPLP. Type FPLP power limited fire alarm plenum cable shall be listed as being suitable for use in ducts, plenums, and other space used for environmental air and shall also be listed as having adequate fire resistant and low smoke producing characteristics. So next we have E, type FPLR. Type FPLR power limited fire alarm riser cable shall be listed as being suitable for use in a vertical run in a shaft or from floor to floor and shall also be listed as having fire resistant characteristics capable of preventing the carrying of fire from floor to floor. F, type FPL. Type FPL power limited fire alarm cable shall be listed as being suitable for general purpose fire alarm use with the exemption of risers, ducts, plenums, and other spaces used for environmental air and shall also be listed as being resistant to the spread of fire. Next we have G, fire alarm circuit integrity, or CI cable, or electrical circuit protective system. Cables that are used for survivability of critical circuits under fire conditions shall meet either 7.60.4.4 G1 or G2 as follows. First, circuit integrity CI cables. Circuit integrity CI cables specified in 7.60.4.4 D, E, and F, and H, and used for survivability of critical circuits shall have an additional classification using the suffix CI. Circuit integrity cable shall only be permitted to be installed in a raceway where specifically listed and marked as part of an electrical circuit protective system as covered in 7.60.4.4 G2. Second, we have electrical circuit protective system. Cables specified in 7.60.4.4 D, E, F, H, and G1 that are part of an electrical circuit protective system shall be identified with the protective system number and hourly rating printed on the outer jacket of the cable and installed in accordance with the listing of the protective system. Next, we have H, coaxial cables. Coaxial cables shall be permitted to use 30% conductivity copper covered steel center conductor wire and shall be listed as type FPLP, FPLR, and FPL cable. Next, we have I, cable marking. The cable shall be marked in accordance with table 7.60.4.1 I. The voltage rating shall not be marked on the cable. Cables that are listed for circuit integrity shall be identified with the suffix CI as defined in 7.60.4.4 G. So, next is J, insulated continuous line type fire detectors. Insulated continuous line type fire detector shall be rated in accordance with 7.60.4.4 C, listed as being resistant to the spread of fire in accordance with 7.60.4.4 D through F, marked in accordance with 7.60.4.4 I, and the jacket compound shall have a high degree of abrasion resistance. Temperature rating shall be marked on the jacket of PLFE cables that have temperature rating exceeding 60 degrees Celsius. The jacket of PLFE cable shall be marked with the conductor size. So we have here another table 7.60.4.4 I cable markings. So we have here cable marking FPL, FP, FPLR, FPL, and then types of FPLP, power limited fire alarm plenum cable, FPLR, power limited fire alarm riser cable, FPL, power limited fire alarm cable. Next, we have Article 7.70, optical fiber cables and raceways. 7.70.1 General. 7.70.1.1 Scope. This article covers the installation of optical fiber cables. This article does not cover the construction of optical fiber cables and raceways. 7.70.1.2 Definitions. See Part 1.0.1. For purposes of this article, the following additional definition apply. Abandoned optical fiber cable. Installed optical fiber cable that is not terminated at equipment other than a connector and not identified for future use with a tag. Cable sheet. A covering over the optical fiber assembly that includes one or more jackets and may include one or more metallic members or strength members. Expose or to accidental contact. A conductive optical fiber cable in such a position that in case of failure of supports or insulation, contact between the cable's non-current carrying conductive members and an electrical circuit may result. Point of entrance. The point within a building at which the optical fiber cable emerges from an external wall from a concrete floor slab. Next we have 7.70.1.3 other articles. Installation of optical fiber cables and raceways shall comply with 7.70.1.3a and b. Only those sections of Chapter 2 and Article 3.0 referenced in this article shall apply to optical fiber cables and raceways. A. Hazardous or classified locations. Listed optical fiber cables shall be permitted to be installed in hazardous locations. The cable shall be sealed in accordance with the requirements of 5.1.2.6 rather, 5.2.2.6, 5.1.16 or 5.6.1.16 as applicable. B. Cables and ducts for dust, loose stock or vapor removal. The requirements of 3.0.1.22a for wiring system shall apply to conductive optical fiber cables. Next, C. Composite cables. Composite optical fiber cables shall be classified as electrical cables in accordance with the type of electrical conductors. These shall be constructed, listed, and marked in accordance with the appropriate article for each type of electrical cable. Next, we have 7.70.1.21 Access to electrical equipment behind panels designed to allow access. Access to electrical equipment shall not be denied by an accumulation of optical fiber cables that prevents removal of panels, including suspended ceiling panels. Next, we have 7.70.1.24 Mechanical execution of work. Optical fiber cables shall be installed in a neat and workmanlike manner. Cables installed exposed on the surface of ceiling and side walls shall be supported by the building structure in such a manner that the cable will not be damaged by normal building use. Such cables shall be secured by hardware including straps, staples, cable ties, hangers, or similar fittings designed and installed so as not to damage the cable. The installation shall also conform with 3.0.1.4d through G and 3.01.1.11 non-metallic cables, ties, and other non-metallic cables accessories used to secure and support cables in other spaces used for environmental air or plenums shall be listed as having low smoke and heat release properties. Next, we have 7.70.1.25 Abandoned cables. The accessible portion of abandoned optical fiber cables shall be removed. Where cables are identified for future use with a tag, the tag shall be sufficient durability to withstand the environment involved. Next, we have 7.70.1.26 Spread of fire or products of combustions. Installations of optical fiber cables and communications raceways in hollow spaces, vertical shafts, and ventilations or air handling ducts shall be made so that the possible spread of fire or products of combustions will not be substantially increased. Openings around penetration of optical fiber cables and communication raceways through fire-resistant rated walls, partitions, floors, or ceilings shall be fire-stopped using approved methods to maintain the fire resistance rating. Next, we have 7.70.2 Cables outside and entering buildings. 7.70.2.1 Overhead or aerial optical fiber cables. Overhead optical fiber cables containing a non-current carrying metallic member entering building shall comply with 8.40.2.1a and b. A. On poles and in span. Where outside plant optical fiber cables and electric light or power conductors are supported by the same pole or are run parallel to each other in span, the conditions described in 7.70.2.1a 1 through A4 shall be met. First, we have relative location. Where practicable, the outside plant optical fiber cable shall be located below the electric light or power conductors. Second, attachment to cross arms. Attachment of outside plant optical fiber cables to a cross arm that carries electric light or power conductors shall not be permitted. Climbing space. The climbing space through outside plant optical fiber cables shall comply with the requirements of 2.25.1.14d. Clearance. Supply service drops and sets of overhead service conductors of 0 to 750 volts running above and parallel to optical fiber cable. Service drops shall have minimum separation of 300 mm at any point in the span, including at the point of their attachment to the building. Clearance of not less than 1000 mm shall be maintained between the two surfaces of the pole. Next, B. Above roofs. Outside plant optical fiber cables shall have a vertical clearance of not less than 2500 mm from all points of roofs above which they pass. So they have two exceptions. First, we have the requirements of 7.70.2.1b shall not apply to auxiliary buildings such as garage and the like. Second, a reduction in clearance above only the overhanging portion of the roof not less than 450 mm shall be permitted. If A. Not more than 1100 mm, optical fiber cable service the cable passes above the roof overhang, and B. The cable is terminated at the through or above the roof raceway or approved support. Third, where the roof has a slope of not less than 100 mm in 300 mm, a reduction in clearance to not less than 900 mm shall be permitted. Next, we have 7.70.2.4 Underground optical fiber cables entering buildings. Underground optical fiber cables entering buildings shall comply with 7.70.2.4a and b. A. Underground system with electric light, power, class 1 or non-power limited fire alarm circuit conductors. Underground conductive optical fiber cables entering buildings with electric light, power, class 1 or non-power limited fire alarm circuit conductors in a raceways, handhold enclosure or manhole shall be located in a section separated from such conductors by means of brick, concrete or tile partitions or by means of suitable barrier. Next, B. Direct buried cables and raceways. Direct buried conductive optical fiber cables shall be separated by at least 300 mm from conductors of any electric light, power or non-power limited fire alarm circuits conductors or class 1 circuit. So next, we have 7.70.2.5 Unlisted cables and raceways entering buildings. A. Conductive and non-conductive cables. Unlisted conductive and non-conductive outside plant optical fiber cables shall be permitted to be installed in building spaces or other than risers. Ducts used for environmental air, plenums used for environmental air, and other spaces used for environmental air where the light of the cable within the building measured from its point of entrance does not exceed 15 meters and the cable enters the building from the outside and is terminated in an enclosure. The point of entrance shall be permitted to be extended from the penetration of the external wall or floor slab by continuously enclosing the entrance. Optical fiber cables in rigid metal conduit RMC or intermediate metal conduit or IMC to the point of emergence. Next, B. Non-conductive cables in raceway. Unlisted non-conductive outside plant optical fiber cables shall be permitted to enter the building from the outside and shall be permitted to be installed in any of the following raceways. First, we have intermediate metal conduit or the IMC. Second, rigid metal conduit or the RMC. Third, we have rigid polyvinyl chloride conduit or PVC. Fourth, electrical metallic tubing or EMT. Unlisted non-conductive outside plant cables installed in rigid polyvinyl chloride conduit or PVC or electrical metallic tubing or EMT shall not permitted to be installed in risers, ducts used for environmental air, plenums used for environmental air, and other spaces for use for environmental air. So next we have 7.70.2.6 metallic entrance conduit grounding. Metallic conduit containing optical fiber entrance cable shall be connected with a bonding conductor or grounding electrode conductor to a grounding electrode in accordance with 7.70.4.1b. Next, we have 7.70.3 protection. 7.70.3.1 grounding or interruption of non-current carrying metallic members of optical fiber cables. Optical fiber cables entering the building or terminating on the outside of the building shall comply with 7.70.3.1a or b. A. Entering buildings. An installation where an optical fiber cable is exposed to contact with electrical light or power conductors and the cable enters the building, the non-current carrying metallic member shall be either grounded as specified in 7.70.4.1 or interrupted by an insulating joint or equivalent device. The grounding or interruption shall be as close as practicable to the point of entrance. B. Terminating on the outside of buildings. In installation where an optical fiber cable is exposed to contact with electrical light or power conductors and the cable is terminated on the outside of the building, the non-current carrying metallic member shall be either grounded as specified in 7.70.4.1 or interrupted by an insulating joint or equivalent device. The grounding or interruption shall be as close as practicable to the point of termination of the cable. Next, we have 7.70.4 grounding methods. 7.70.4.1 entrance cable bonding and grounding. Where required, the non-current carrying metallic members of optical fiber cables entering buildings shall be bonded or grounded as specified in 7.70.4.1a through d. A. Bonding conductor or grounding electrode conductor. First, we have insulation. The bonding conductor or grounding electrode conductor shall be listed and shall be permitted to be insulated, covered, or bare. Second, material. The bonding conductor or grounding electrode conductor shall be copper or other corrosion-resistant conductive material, stranded or solid. Third, size. The bonding conductor or grounding electrode conductor shall not be smaller than 2.0 mm squared. It shall have a current carrying capacity not less than that of the grounded metallic member. The bonding conductor or grounding electrode conductor shall not be required to exceed 14 mm squared. Fourth, length. The bonding conductor or grounding electrode conductor shall be as short as practicable. In one and two family dwellings, the bonding conductor or grounding electrode conductor shall be as short as practicable, not to exceed 6,000 mm in length. So fifth, run in straight line. The bonding conductor or grounding electrode conductor shall be run in a straight line as practicable. Sixth, physical protection. Bonding conductors and grounding electrode conductors shall be protected where exposed to physical damage. Where the bonding conductor or grounding electrode conductor is installed in a metal raceway, both ends of the raceway shall be bonded to the contained conductor to the same terminal or electrode to which the bonding conductor or grounding electrode conductor is connected. Next, B. Electrode. The bonding conductor and grounding electrode conductor shall be connected in accordance with 7.70.4.1 B1, B2, or B3. In buildings or structures with an intersystem bonding termination, if the building or structure serve as an intersystem bonding termination as required by 2.50.5.5, the bonding conductor shall be connected to the intersystem bonding termination. Second, in buildings or structure with grounding means, if an intersystem bonding termination is established, 2.50.5.5a shall apply. First, the building or structure grounding electrode system as covered in 2.50.3.1. Second, the grounded interior metal water piping system within 1,500 mm from each point of entrance to the building as covered in 2.50.3.3. Third, the power service accessible means external to enclosure using the options identified in 2.50.5.5a exemption. Fourth, the non-flexible metallic power service raceway. Fifth, the service equipment enclosure. Sixth, the grounding electrode conductor or the grounding electrode conductor metal enclosure of the power service. 7. The grounding electrode conductor or the grounding electrode of a building or structure disconnecting means that is grounded to an electrode as covered in 2.50.2.13. Next, we have in building or structure without intersystem bonding termination or grounding means. If the building or structure serve has no intersystem bonding termination or grounding means, as described in 7.70.4.1b, to the grounding electrode conductor shall be connected to either of the following. To any one of the eventual grounding electrodes described in 2.50.3.3 A1, E2, E3, or A4. Second, if the building or structure serve as no grounding means, as described in 7.70.4.1b, 2 or B3, A, to any one of the individual grounding electrodes described in 2.50.3.3a, 7 and A8, or to a ground rod or pipe not less than 1,500 mm in length and 12.7 mm in diameter, driven where practicable into permanently damp earth and separated from lightning protection system conductors as covered in 8.0.2.10 and at least 1,800 mm from electrodes of the other system. Stem, hot water pipes, or lightning protection system conductors shall not be employed as electrodes for non-current carrying metallic members. Next, we have electrode connection. Connections to grounding electrodes shall comply with 2.50.3.21. Next, we have bonding of electrodes. A bonding jumper not smaller than 14 mm squared copper or equivalent shall be connected between the grounding electrode and power grounding electrode system at the buildings or structure served where separate electrodes are used. Next, we have 7.70.4.7 grounding and bonding of entrance cables at mobile homes. Grounding. Grounding shall comply with 7.70.4.7 A1 and A2. First, where there is no mobile home service equipment located within 9,000 mm of the exterior wall of the mobile home, it serves the non-current carrying metallic members of optical fiber cables entering the mobile home shall be grounded in accordance with 7.70.4.1 B3. Second, where there is no mobile home, disconnecting means grounded in accordance with 2.50.2.13 and located within 9,000 mm of the exterior wall of the mobile home. It serves the non-current carrying metallic members of optical fiber cables entering the mobile home shall be grounded in accordance with 7.70.4.1 B3. Next, we have bonding. The grounding electrode shall be bonded to the metal frame or available grounding terminal of the mobile home with a copper conductor not smaller than 3.5 mm squared under either of the following conditions. First, we have where there is no mobile home service equipment or disconnecting means as in 7.70.4.7a. Second, where the mobile home is supplied by cord and plug. Next, we have 7.70.5 installation methods within buildings. 7.70.5.1 raceways and cable routing assemblies for optical fiber cables. A. Types of raceways. Optical fiber cables shall be permitted to be installed in any raceways that complies with either 7.70.5.1A, 1 or A2, and any cable routing assemblies installed in compliance with 7.70.5.1C. First, raceways recognized in Chapter 3. Optical fiber cable shall be permitted to be installed in any raceway included in Chapter 3. The raceway shall be installed in accordance with the requirements of Chapter 3. Second, communications raceways. Optical fiber cable shall be permitted to be installed in plenum communications raceways, listed riser communication raceways, and general purpose communication raceways selected in accordance with Table 8.0.5.45b, listed in accordance with 8.0.5.4, and installed in accordance with 3.62.2.15 through 3.62.2.47, where the requirements applicable to electrical non-metallic tubing or ANT apply. B. Raceway fill for optical fiber cables. Raceway fill for optical fiber cables shall comply with either 7.70.5.1 B1 or B2. First, without electric light or power conductors. Where optical fiber cables are installed in raceway without electric light or power conductors, the raceway fill requirements of Chapter 3 and 9 shall not apply. Second, non-conductive optical fiber cables with electric light or power conductors. Where non-conductive optical fiber cables are installed with electric light or power conductors in a raceway, the raceway fill requirements of Chapter 3 and 9 shall apply. C. Cable routing assemblies. Optical fiber cables shall be permitted to be installed in a plenum cable routing assemblies, riser cable routing assemblies, and general purpose cable routing assemblies selected in accordance with Table 8.0.5.45c, listed in accordance with 8.0.6.13, and installed in accordance with 8.0.5.1c and 8.0.5.4. Next, we have 7.70.5.4 installation of optical fiber cables. Installation of optical fiber cables shall comply with 7.70.5.4a through J. Installation of raceway shall comply with 7.70.5.1. A. Listing. Optical fiber cables installed in buildings shall be listed in accordance with 7.70.6.1. B. Ducts specifically fabricated for environmental air. The following cables shall be permitted in ducts specifically fabricated for environmental air as described in 3.0.1.22b if they are directly associated with the air distribution system. First, up to 1,200 mm of types of OFNFP and OFCP. Second, types of OFNP, OFCP, OFNR, OFCR, OFNG, OFCG, OFN, and OFC installed in raceways that are installed in compliance with 3.0.1.22b. Next, other spaces used for environmental air or plenums. The following cables shall be permitted in the other spaces used for environmental air is described in 3.0.1.22c. First, we have types OFNP and OFCP. Second, types OFNP and OFCP installed in plenum communications raceways listed in accordance with 8.0.6.13. Third, types OFNP and OFCP installed in plenum cable routing assemblies listed in accordance with 8.0.6.13. Fourth, types OFNP and OFCP supported by open metallic cable trays or cable tray systems. Fifth, types OFNP, OFCP, OFNR, OFCR, OFNG, OFCG, OFN, and OFC installed in raceways that are installed in compliance with 3.0.1.22c. Types 6. Types of NP, of CP, of NR, of CR, of NG, of CG, OFN, and of OFC, supported by solid bottom metal cable trays with solid metal covers in other species used for environmental air or plenums as described in 3.01.22c. 7. Types of NP, of CP, of NR, of CR, of NG, of CG, OFN, and OFC installed in plenum communications raceway, riser communications raceway, or general purpose communication raceway listed in accordance with 8.0.6.13 or supported by solid bottom metal cable trays with solid metal covers in other species used for environmental air plenums as described in 3.01.22. C. Next we have D. Risers. Cables in vertical runs. The following cables in vertical runs penetrating one or more floors and in vertical runs in a shaft. First we have type of NP, of CP, of NR, and of CR. Second, types of NP, of CP, of NR, and of CR installed in. First, plenum communications raceways. B. Plenum cable routing assemblies. C. Riser communication raceways. D. Riser cable routing assemblies. Next, we have risers. Cables in metal raceways. The following cable shall and inner ducts be permitted in metal raceways in riser having fire straps at each floor. First, types of OFNP, of CP, of NR, of CR, of NG, of OFCG, OFN, and OFC. Second, types of NP, of CP, of NR, of CR, of NG, of OFCG, of N, and of OFC installed in. A. Plenum communication raceways or inner duct. B. Riser communication raceways or inner duct. C. General purpose communication raceways or inner duct. Next we have risers. Cables in fireproof shafts. The following cables shall be permitted to be installed in fireproof riser shafts having fire stop at each floor. First, types of NP, of CP, of NR, of CR, of NG, of CG, and OFN, and OFC. 2. Types of NP, of CP, of NR, of CR, of NG, of CG, OFN, and OFC installed in. First, A. Plenum communication raceways. B. Plenum cable routing assemblies. C. Riser communication raceways. D. Riser cable routing assemblies. A. General purpose communication raceways. F. General purpose cable routing assemblies. Next we have G. Risers. 1 and 2 family dwellings. The following cables shall be permitted in 1 and 2 family dwellings. First, types of NP, of CP, of NR, of CR, of NG, of CG, of N, and of OFC. Second, types of NP, of CP, of NR, of CR, of NG, of CG, of N, and OFC installed in. First, plenum connection raceways. B. Plenum cable routing assemblies. C. Rising communication raceways. D. Riser cable routing assemblies. E. General purpose communication raceways. F. General purpose cable routing assemblies. Next we have cable trays. The following cables shall be permitted to be supported by cable trays. First, types of NP, of CP, of NR, of CR, of NG, of CG, of N, and OFC. Second, types of NP, of CP, of NR, of CR, of NG, of CG, of N, and of OFC installed in. First, A. Plenum communication raceways. B. Riser communication raceways. C. General purpose communication raceways. Next we have I. Distributing frames and cross connect arrays. The following cables shall be permitted to be installed in distributing frames and cross connect arrays. First, types of NR, types of NFE, of CP, of NR, of CR, of NG, of CG, of N, and of OFC. Second, types of NP, of CP, of NR, of CR, of NG, of CG, of N, and of OFC installed in first A. Plenum Communication Raceways. B. Plenum Cable Routing Assemblies. C. Riser Communication Raceways. D. Riser Cable Routing Assemblies. E. General Purpose Communication Raceways. F. General Purpose Cable Routing Assemblies. Next, we have other building locations. The following cables shall be permitted to be installed in buildings locations other than location covered in 7.70.5.4b through I. First, types of NP, of CP, of NR, of CR, of NG, of CG, of N, and of C. Second, types of NP, of CP, of NR, of CR, of NG, of CG, of N, and OFC installed in. First, we have A. Plenum Communication Raceways. B. Plenum Cable Routing Assemblies. C. Riser Communication Raceways. D. Riser Cable Routing Assemblies. E. General Purpose Communication Raceways. F. General Purpose Cable Routing Assemblies. Third, types of NP, of CP, of NR, of CR, of NG, of CG, of N, and of C installed in a raceways of a type recognized in Chapter 3. Next, we have 7.70.5.5 grounding. Non-current carrying conductive members of optical fiber cable shall be bonded to a grounded equipment rack or enclosure, or grounded in accordance with the grounding methods specified by 7.70.4.1b2. Next, we have 7.70.5.24 installation of optical fiber cables and electrical conductors. A. With conductors for electric light, power, class 1, non-power limited fire alarm, or medium power network powered broadband communication circuits. When optical fibers are within the same composite cable for electric light, power, class 1, non-power limited fire alarm, or medium power network powered broadband communication circuits operating at 1000 volts or less, they shall be permitted to be installed only where the functions of the optical fibers and the electrical conductors are associated. Non-conductive optical fiber cables shall be permitted to occupy the same cable tray or raceways with conductors for electric light, power, class 1, non-power limited fire alarm, type ITC, or medium power network powered broadband communication circuits operating at 1000 volts or less. Conductive optical fiber cables shall not be permitted to occupy the same cable tray or raceways with conductors for electric light, power, class 1, non-power limited fire alarm, type ITC, or medium power network powered broadband communication circuits. Optical fibers in composite optical fiber cables containing only current carrying conductors for electric light, power, or class 1 circuits rated 1000 volts or less shall be permitted to occupy the same cabinet, cable tray, outlet box, panel, raceway, or other termination enclosure with conductors for electric light, power, or class 1 circuits operating at 1000 volts or less. Non-conductive optical fiber cables shall not be permitted to occupy the same cabinet, outlet box, panel, or similar enclosure housing the electrical termination of an electric light, power, class 1, non-power limited fire alarm, or medium power network powered broadband communication circuit. B. With other circuits, optical fibers shall be permitted in the same cable, and conductive and non-conductive optical fiber cables shall be permitted in the same raceway, cable tray, box enclosure, or cable routing assembly with conductors of any of the following. First, we have class 2 and class 3 remote control signaling and power limited circuits in compliance with Article 6.45 or Parts 7.25.1 and 7.25.3. Second, power limited fire alarm system in compliance with Parts 7.60.1 and 7.60.3. Third, communication circuits in compliance with Parts 8.0.1 and 8.0.5. Fourth, community antenna television and radio distribution system in compliance with parts 8.20.1 and 8.20.5. Fifth, low power network powered broadband communication circuits in compliance with parts 8.30.1 and 8.30.5. Next, we have C, support of optical fiber cables. Raceways shall be used for their intended purpose. Optical fiber cables shall not be strapped, taped, or attached by any means to the exterior of any conduit or raceways as means of support. Next, we have 7.70.5.45, application of listed optical fiber cables. Permitted and non-permitted application of listed optical fiber cables shall be as indicated in Table 7.70.5.45a. The permitted application shall be subject to the installation requirement of 7.70.5.1 and 7.70.5.4. The substitution for optical fiber cables in Table 7.70.5.45b and illustrated in Figure 7.70.5.45 shall be permitted. Next, we have 7.70.6 listing requirements. 7.70.6.1 Optical fiber cables. Optical fiber cables shall be listed and identified in accordance with 7.70.6.1a through F and shall be marked in accordance with Table 7.70.6.1. Optical fiber cables shall have a temperature rating of not less than 60 degrees Celsius. Temperature rating shall be marked on the jacket of optical fiber cables that have a temperature rating exceeding 60 degrees Celsius. So you can see here that we have here tables. We have a table 7.70.5.45a application of listed optical fiber cables in buildings. So you have here the of their applications. Then the type of cable type with OFNP, OFCP, OFNR, OFCR, OFNG, OFCG, OFN, and OFC. Na yung mga corresponding cable type na gamit sa mga different application na prescribed cable sa different application. Mga table. Then we have here other figure. We have figure 7.70.5.45 cable substitution hierarchy. Natin makita itong plenum, riser, general purpose, non-conductive, so FNV to FCP, conductive, sa riser, FNR to FCR, general purpose, FNG, FN to FCG, FC. Then we have here another table, 7.70.5.45b, cable substitution. Cable type, so OFNP, OFCP, OFNR, OFCR, OFNG, OFN, OFCG, OFG. Permitted substitution, so pwede sa OFNP, Y pwede ma-substitute. Sa OFCP, pwede ang OFNP gamitan. Sa FNR, OFNP gamitan. Sa OFCR, OFNP, OFCP, OFNR gamitan. Sa OFNG, OFN, OFNP, OFNR gamitan. Sa OFCG, OFNP, OFCP, OFNR, OFCR, OFNG, OFN ang pwede gamitan. So, A. Types of OFNP and OFCP. Types of OFNP and OFCP, non-conductive and non-conductive optical fiber plenum cable shall be suitable for use in ducts, plenums, and other space used for environmental air and shall also have adequate fire resistant and low smoke producing characteristics. B. Types of NR and FCR. Types of OFNR, FCR, non-conductive and conductive optical fiber riser cables shall be suitable for use in vertical run in a shaft or from floor to floor and shall also be listed as have the fire resistant characteristics capable of preventing the carrying of fire from floor to floor. Next we have C. Types of NG and FCG. Types of NG and FCG non-conductive and conductive general purpose optical fiber cable shall be suitable for general purpose use with the exemption of risers and plenums, and shall also be resistant to the spread of fire. D. Ties of OFN, OFC. Ties of OFN and OFC, non-conductive and conductive optical fiber cables shall be listed as being suitable for general purpose use with the exemption of risers, plenums, and other species used for environmental air, and shall also be listed as being resistant to the spread of fire. Next we have E. Circuit integrity or CI, cable for electrical circuit protective system. Cables that are used for survivability of critical circuits under fire conditions shall meet either 7.70.6.1 E, I, or E2. So 1. Circuit integrity CI cables. Circuit integrity CI cables specified in 7.70.6.1a through D and used for survivability of critical circuits shall have an additional classification using the suffix CI. In order to maintain its listed fire rating, circuit integrity cable shall only be installed in free air. Second, fire resistive cables. Cables is specified in 7.70.6.1a through D and 7.70.6.1a 1 that are part of an electrical circuit protective system shall be fire resistive cable and identified with the protective system number on the product or on the smallest unit container in which the product is packaged and installed in accordance with the listing of the protective system. F. Field assembled optical fiber cables. Field assembled optical fiber cables shall comply with 7.70.6.1 F1 through 4. First, we have the specific combination of jacket and optical fibers intended to be installed as field assembled optical fiber cable shall be one of the types in 7.70.6.1a, B, or D, and shall be marked in accordance with table 7.70.6.1. Second, the jacket of a field assembled optical fiber cable shall have a surface marking indicating the specific optical fibers with which it is identified for use. Third, the optical fiber cable shall have permanent marking such as marker tape indicating the jacket with which they are identified for use. So fourth, we have the jacket without fiber shall meet the listing requirements for communication raceways in 8.0.6.13a, B, or C in accordance with the cable marking. Next, we have 7.70.6.2, the grounding devices. Where bonding or grounding is required, devices used to connect a shield, a sheet, or non-current carrying metallic members of a cable to a bonding conductor or grounding electrode conductor shall be listed or be part of listed equipment. So we have here another table 7.70.6.1, cable markings. So you can see here the cable marking under type. So example of OFNP, its type non-conductive optical fiber plenum cable. OFCP, conductive optical fiber plenum cable. Or OFNR, non-conductive optical fiber riser cable. OFCR, conductive optical fiber riser cable. OFNG, non-conductive optical fiber general purpose cable. OFCG, conductive optical fiber general purpose cable. OFN, non-conductive optical fiber general purpose cable. OFC, conductive optical fiber general purpose cable. That's all of our report about chapter 7. In behalf of my co-reporters, we say thank you for listening and God bless everyone.